last unit that we're reviewing is Unit 5. Unit 5 is what we just took our test on before the vacation. Alright, and all we were doing here was we were using our factoring techniques, and we factored and we simplified. Okay, so what we're going to do in these problems, we are going to factor the numerator and the denominators, and then we're going to cancel anything that we can. So what I'm going to do first thing is rewrite my fraction bar. And then I'm going to look at the numerator first, so that's the top. What method will I use to factor this numerator? Diamond method, good. So we are looking for two numbers that multiply to 25 and add up to 10. 5 and 5. So does anybody remember what special case this is? It's a perfect square trinomial.
Perfect square trinomial.
Mm-hmm.
Very
good. And then the denominator, x squared minus 5, is a difference of two squares. So that's just going to be x plus 5 times x minus 5. Right. And so then what cancels here? Not x5, x plus 5, and x plus 5. Okay, only one on top for each one on bottom. Okay, one thing that I saw on the test when we took this one is that some people were canceling the x plus 5 on top with the x plus 5 on top. You can only cancel one on top for every one on bottom. Okay, and it has to be all or nothing. Okay, so what is my answer? What am I left with? X plus 5 over x minus 5. Question. Can I cancel out positive x and positive x? This with that?
No.
How come? Because it's all or nothing. There's a plus in between them. So these guys are actually like they're in parentheses, right? We either have to be able to cancel the whole parentheses or we leave it as it is. So this is my answer. Okay? Example 2. We have 3x plus 1 over 3x squared plus 7x plus 2. So first thing I'm going to do before I even start is I'm going to rewrite my fraction bar. Okay, and can I factor 3x plus 1?
Yes.
The numerator.
No.
Is there a GCF in there?
Nope.
No. Is it a difference of two squares?
No.
No. Is it a perfect square trie?
No.
No. Is it a trinomial?
No.
No. Is it bottoms up?
No.
No. So we cannot factor it. So we keep it as 3x plus 1.
Plus uno.
Mm-hmm. Okay. What about the denominator? What method will I use here? Okay, I'm hearing two different things. How many vote for diamond? How many vote for bottoms up?
I don't know what bottoms up is.
Very good. We have to use bottoms up because there's a number in front of the x squared. Okay? We're doing it right now. So, first step of bottoms up is what? Carlos? Look for a GCF. Do we have one? No. Next step of bottoms up is what, Bobby? Very good. Multiply what? I multiply 3 times 2. So I take that 3 and I bring it over to the 2. So that's going to give me x squared plus 7x plus 6. Okay, next step. Tommy. We're doing bottoms up. We multiplied 3 times 2. What do I do here? Okay, we have to know how to do it. Abby? We can do diamond on this. Okay, so we're looking for diamond. Two things that multiply to positive 6 and add up positive 7. 1 and 6. Okay, so this factors you. X plus 1 times x plus 6. Okay, am I done with bottoms up? No. What's my next step, Lupita? Okay, at the beginning I multiplied by 3, so now to undo that, what do I have to do? Right, I divide by 3. Okay, what's the next step? Kylie, what's my next step? Okay, can somebody help her out? Jared?
Don't you put on the x plus 1, don't you put, or on the x plus 6, don't you put the, make it go up?
We can reduce the fraction, right?
Yeah.
Okay, we can't reduce 1 over 3, but we can reduce 6 over 3. Okay, so that reduces to just 2. Okay, and I still have a bottom here, so what do I have to do, Macy? Bring that 3 up. That's the bottoms up part. Okay, so what is my answer? 3x plus 1 times
X plus 2.
times x plus 2. So that goes at the bottom.
Do you have to include a 3?
We do have to include the 3.
Maybe we just put an X.
It's wrong. Very good. We have up here 3x plus 1, and I like to put it, I forgot to do it, I like to put it in parentheses so that we remember that it's stuck together. Okay, and 3x plus 1 and 3x plus 1 cancel. Okay, so what is left on top? A 1. Have to put a placeholder there. And what's left on bottom? X plus 2. Am I done? Yep. Okay. Next example 3 is multiplication. Okay. Multiplication, we're pretty much going to be doing the same thing. What we want to do first is factor everything. So right now, by yourselves, or you can work with your partner, I want you to factor every single part of this. So we should get a fraction, all factored out, times a fraction, all factored out. So will you guys factor both of those right now? Alyssa, this one right here, how did you factor that?
Factor out an x.
Factor out an x. So that's going to be x plus 3, correct?
Yes.
Okay, Matthew, what about this one?
I got
X minus 4, x plus 1. What method did you use there?
I used diamond.
Good, perfect. So he used diamond right here and got x minus 4 times x plus 1. Someone from this side. Ashley? This one right here. You used diamond method, and what'd you get? Very good. X minus 4 times x minus 1. And did I do... No, I need this side. Diego. This one. How'd you factor that? You used diamond, and what'd you get? 2 times negative 1 does not give us negative 3. X plus 3 times x minus 1. Perfect.
I got it right?
Yes, you did. Okay. So everybody needs to check to make sure they got this for their factored, yes?
Yes.
Okay, Alyssa, are you going to tell us our next step?
Yeah.
Okay, what is it?
You have to cancel it.
We have to cancel whatever we can. Now remember, we can only cancel 1 on top for every 1 on bottom. So does anything cancel with x?
No.
No. What about x plus 3?
Yes, x plus 3.
X plus 3 and x plus 3 cancel. What else cancels?
X minus 4.
X minus 4, x minus 4. Anything else?
X minus 1.
X minus 1 and x minus 1. So what am I left with for my answer?
X over x.
Very good. X over x plus 1. Yep, that's it. Alright, you can.
Okay.
Okay. Question. Now we have a division problem for number 4. What do I need to do before I even start factoring? Keep it, change it, flip it. So let's rewrite it right now. That's going to be 2x squared minus 5x plus 2. Keep it. Over x squared plus x minus 20. Change it. What does that mean? Change the sign to multiplication. And flip it. We take the reciprocal, right?
Yeah.
So that's going to be x squared minus 4x over 4x squared minus 1. And now it's exactly like number 3. So really quick, I'm going to have you do this by yourselves, but I just want to go over the methods. What method will I use after here? Bottoms up. What about here? Diamond. Wait.
Wait, no,
Dip. Oh, no.
red.
I don't see GCF.
Oh, yeah.
And what about this one? That's a difference of 2 squares. Okay, so factor those right now. Okay. What method am I going to use to factor this one, Colton? This one?
No, bottoms up.
Bottoms up. So we're going to use bottoms up on 2x squared minus 5x plus 2. So what do I do first on bottoms up, Keely?
Oh, I got a question.
Oh, you had a question. Sorry, it's your question. So we are using bottoms up here because there's a number in front of the x squared. So what is my first step of bottoms up, Ivanka? We're doing bottoms up on the top. What's my first step?
You multiply 2 to the 2 to the n.
Very good. I multiplied 2 times 2, so that's going to give me x squared minus 5x plus 4. Okay. What do I do next? Tommy, what do I do next? Same question I asked you last time. Diamond method. So I'm looking for the two numbers that multiply to positive 4 and add up to negative 5, Jared? Negative 5. Negative 4. Negative 1.
Oh, God. 5 and negative 1.
Those don't multiply to positive 4. Okay. Alright, what is my next step of bottoms up? Let me see this side. Justin, what's my next step in bottoms up? Brandon, what do I do? I divide by 2. Okay, Johnny, what's my next step? Reduce. So 2 and 4 reduces to 2. And I bring that bottom up. So what does this guy factor to? Okay, guys, what does it factor to? X minus 2 times 2x minus 1. Thank you. Okay, that's the top. Okay, what method do I use here? Todd, what method do I use here? Diamond. Okay, what'd you get? Todd, what'd you get when you used diamond? On the bottom right here. Two numbers that multiply to negative 20 and add up to positive 1. X minus 4, X plus 5. Good. Okay. This numerator right here, how does that one factor? Brianna. For right here, what method did you use? Very good. We use GCF. So we have an X, and that leaves us with X minus 4. Okay, the last one. We have this one right here. How does that one factor, Julian? Go down the list. Don't just pick bottoms up because there's a number in front of the x squared. Right, you need to go down the list. GCF. There's not a GCF. Okay, is it a difference of two squares? Okay. So how does it factor them? Nope. Okay, how do I use difference of two squares here? Alyssa.
2x plus 1.
2x plus 1, 2x minus 1. Okay, what canceled, guys?
X minus 4, X minus
2x minus 1,
X minus 4,
x minus 4, x minus 4. Is that it? Okay. So then for my answer, I just multiply everything that's left over. So what's left over on the top? There's an x times x minus 2. And what's left on bottom?
X plus 5 times 2x.
Very good. X plus 5 times 2x plus 1. And that's your answer. Okay? Example 5. We have x squared plus 2x over x plus 5 plus 3x over x plus 5. So now we're adding. Can I add these two? How come? Because they have common denominators. My common denominator is x plus 5. What we're going to do is I'm going to rewrite, put it all over the common denominator, x plus 5. And what do I do with the numerators?
Add them.
I add them. So this is going to be x squared plus 5x. Okay. Is that my answer?
No.
No, we can actually simplify this. Okay, look at the numerator here. Does anything factor? The x. We have a GCF of x in here. So if I factor out an x, what am I left with? X plus 5. All of that is over x plus 5. So we can cross them out. So the answer is x.
So that's X?
Yep.
Okay.
Which is why we always want to factor first before we say that's our final answer. Okay? Example 6. Example 6. Can I add these two? How come? They do not have a common denominator, so we need to find the common denominator. Okay, so what is my LCD going to be? We have to use the 8, and we have to use the x. So my LCD is going to be 8x. So I need to look at each of these. Of 5 over x, what am I missing to get to be a denominator of 8x? Well, I have an 8, so I'm missing just an x. So we're going to multiply top and bottom by x. Okay?
On the other side, you need 4.
On the other side, I'm only missing a 4, so we're going to multiply top and bottom by 4. Okay, so that's going to be what? X times 5 gives me 5x. 8 times x? 8x. Plus 3 times 4? 12. Over 8x. Okay, now can I add them?
Yeah.
Now I can add them because we have common denominators. So we're going to put the whole thing over 8x.
It's just going to be 5x plus 12.
5x plus 12. Can I factor that at all? No, so that's my answer.
Oh, the next one was hard.
Okay?
Those are the ones that I struggled with.
All right, example 7. This is called a complex fraction, and it looks pretty complex, right? Okay, what we have to do here is the first thing, we want to find the LCD. So we're looking at the denominators. X, 4x, and 8. What is my LCD there? 8x. Good. X goes into 8x, right? 4x goes into 8x. And 8 goes into 8x. So what we're going to do is we are going to multiply everything by 8x. Okay? We multiply everything by 8x first. And then we start canceling stuff. 8x and x, what cancels there? The x's. What about here? Yeah, the x's cancel, and 4 goes into 8 twice. And what about here? 8. So what are we left with? 8 times 3 gives me 24 over 2x plus 1x. Very good. Or 2x plus x, right? Okay, what would I do next? Combine like terms. So that would be on the denominator 3x, and on top is still 24. And now what? We can reduce a little bit. 3 goes into 24 8 times. So my answer would be 8 over x. Very good. Okay, we're not going to have time to go through example 8 all the way, but we can at least write down the formula. What was the formula for these? Does anybody remember? Yep. Okay, so we have together times. I'm just writing that as CT over. What's together over? Individual. Plus? Together over individual. And what does that equal? 1. Okay? You have enough to be able to do that homework assignment, so we will check it all tomorrow.